Hello and welcome to the Daily Space for today, March 4th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. We have a fast-paced group of stories to bring you today, and as always, thank you for being here. And if you want, please feel free to tweet out that we're doing this and help increase our audience and increase the number of people out there who know, well, what's going on in the universe. In today's top story, we have a story of planet Earth getting hit with rocks. It has long been known that worlds like our moon, Mars, other rocky objects throughout the solar system have extremely cratered surfaces. Trying to understand our own planet's surface, however, has been somewhat thwarted by, well, foliage, trees, humans, all these things that serve to cover up the craters on our particular surface. In addition to all of these factors, we know that our own planet is recycling its land mass, taking some of the oldest craters and plunging them deep into the core of the planet and erasing them forever. And this means that trying to understand our Earth's cratered history has been difficult, but it's not impossible. And one of the truly amazing things is today, with the advent of things like Google Maps, with the growing amount of Earth imagery that we have that allows us to understand the fine-scale differences in what is the density of the planet from one point to another. All of this scientific imagery combines together to allow us to be finding craters even today. Recently, we've brought you stories about how a new crater had been found on... Sorry, there is a bird behind me in the bird feeder that is tweeting really loudly, and I apologize for the audio distraction. We've recently discovered that there are two different craters hidden under the ice on Greenland. Well, today we have two new stories coming out telling us about one crater that hides beneath the jungles of Nicaragua and another that is out in the grasslands of Western Australia. We continue to be able to identify these craters by using these global maps that allow us to, well, essentially look for circular depressions on the surface of our planet. And when we find them, astronomers, planetary scientists rather, go out, well, in this case, traipsing through Western Australia, looking for the very specific minerals that only occur when our planet gets shocked by space rocks. These particular minerals can be in the form of what are called breccia. This is earth rock that has been melted and rehardened during the impact event. And in Nicaragua, rather than finding breccia, what they found instead was breccia containing tektites specifically. What they found instead in Nicaragua was glass that had shocked silicon quartz crystals inside of it. These shocked crystals only form, well, during impact events. So we have two different cases of two different craters that, well, we didn't know about before. So it appears that our planet has many times in the past, over and over and over, been hit with rocks from space. Now, these two craters that were just discovered are both they're at 12 kilometers and 14 kilometers, we believe, possibly a little bit larger. It's hard to tell if we're seeing the inner or the outer edge of the crater rims. This is the size of many small towns, small cities. So not only are we finding craters, but we're finding craters that would have done a really good job at ruining a lot. Now, luckily, it appears that The crater that was found in Nicaragua occurred about 800,000 years ago, and the one that occurred in Western Australia actually appears to have taken place during the Cretaceous period about 85 million years ago. So there weren't human villages and civilizations around to be destroyed, but it definitely was a bad day for the big life forms of the past. Our Earth is a planet traveling around a star, getting hit by space rocks on a regular basis. Don't forget how lucky you are that we've made it as far as we have. Now, in other news coming to us from the red planet, we have word that the thermal instrument on board the InSight spacecraft, which had been earlier deployed, has completed its first 4-hour hammering event. Now, in this artist illustration, you can get a better sense of what is going on. We have the InSight lander has landed on the surface of Mars. It deployed its seismic unit earlier, and now it's working on having deployed its thermal instrument. It has to, burrow it down beneath the surface. This is part of why it's called a mole. And the way that it is burrowing itself down is it has within it the ability to slowly draw up the hammering device and then slam it downwards. And this action has the ability of taking that plunger that they have and forcing it downwards over and over and over again. Ultimately, they hope to get more than 3 meters beneath the surface. However, to do that, they have to apparently get past some rocks first. Now, they're only doing this 4 hours of hammering at a time. During that 4 hours, there will be roughly 4,000 hammer blows. And during that first 4-hour, hammerathon, they hit at least one rock that caused the plunging down hammer system to tilt about 15 degrees. It continued hammering. It was able to keep going downwards, make it past the rock, and then it found another rock, and they're just going to keep going. And work using one of these kinds of instruments here on the planet Earth has shown that the instrument does have the capacity to get around small rocks. There's a lot of rocks in the Martian soil is the first thing we are learning. We knew there'd probably be rocks, but 2 in the first 4 hours has got to be frustrating to the scientists. So here we are waiting for the second hammering series to go, and that will be at some point in the further weeks. Now, the cable that the hammering device is on is about 5 meters long and has 14 different temperature sensors along it. So it's going to be able to measure the temperature as we deploy the hammering device. Here's to hoping that there aren't too many more rocks in the future of this device. Now, moving on to our final story of the day. Dark matter continues to find ways to perplex us. I'm not sure how else to describe this story. What we see here is 2 different images of galaxies. On the right, we have a low-density galaxy cluster. On the left, we have a significantly higher density one. And what we see in both cases is a map of the dark matter in these systems. So I'm going to go ahead and just read the caption that came with this image, because this is the kind of science that's just kind of perplexing. And when I first read this caption, I went, That doesn't make sense. So what the caption reads is, astronomers observed that the dark matter does not seem to clump very much in small galaxies, but their density peaks sharply in big systems such as clusters of galaxies. It has been a puzzle why different systems behave differently. So what we are observationally discovering is that when we look at systems that have a low overall mass, they have dark matter. They're often dark matter dominated, in fact. But that dark matter is like, I'm not going to get near any of the other dark matter particles. I'm going to just sit here and mark my territory. And all these different maps are showing us that you end up with a flat distribution, more or less, of dark matter in these lower mass systems. When you increase the mass of the system, the dark matter starts to behave more like what we expect of stuff. It clusters up in the center of the gravity well and then decreases in density as you move out of the gravity well. Now, to try and explain this, really weird physics is required. What they determined is that in the lower density, the lower mass systems, the dark matter acts like a lot of ricocheting billiard balls, where if you start throwing the balls around, they're just going to bounce around the table, and eventually you get a smooth distribution of billiard balls on the table. Now, that's the analogy they use. A better way to think of it is, in any given room, the molecules of gas in the room are all bouncing off of each other, and they smooth out their velocities so that if I go to the corner of my room, I'm not going to suddenly asphyxiate because there's no oxygen. The gas in this room is smoothly distributed. Now, in higher energy, higher mass density situations, it appears that at a certain point, the collisions start to behave differently. And in these higher density systems, the dark matter stops behaving like gas in a room and instead starts clumping up when these collisions occur, more like if your billiard balls were made of clay, causing them to sometimes slam together and form a bigger object, and sometimes to just scatter off of one another. This is new information. This is a new way of looking at this completely weird form of matter that we don't fully understand. And this is just a first result. It's going to take more thinking to see, can we figure out more about what we can say about dark matter particles before we actually capture one in a lab. We're not there yet, but new information gets us one step closer to understanding what dark matter is. It would be so useful if we could just reach out and grab it, but we haven't figured out how to make it appear in a lab yet. Onward and upward. Now, this isn't news, but before I go to taking your questions, and don't forget to @CosmoQuestX when you type them in, I'm going to remind you that you can sign up to join me and some of the other faces you know from around Twitch at Joshua Tree Park this summer out in California. We are going to be doing an all-star star party. It's going to be me, Fraser Kane, Paul Matt Sutter, Michael Gauthier, and of course, Skylius. So please, if you want to go on a posh vacation, someplace with amazing landscapes, this is your chance to join us out under the stars. Now, if June is a little too soon for you, I will be doing a tour in late August, starting from Tucson, Arizona, traveling up through the desert Southwest, all the way up to Las Vegas, baby. So these are your chances to join us out under the stars. And now I will take your questions while you're typing them in. Station identification time. You are watching The Daily Space right here on CosmoQuest X on Twitch. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. The Daily Space comes to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. In addition to the Daily Space, we also bring you, with host Annie Wilson, Sunday Science Hour, and a whole variety of launch, landing, and other space special events when they don't occur so much in the middle of the night that, failure to awake occurs. So please give us a follow. Follows are free, and it will help you find out every time we go live. I need to pause and thank Fenrig for the sub. Thank you so very much. I'm looking to see how many months it has been. It's not telling me. 9 months. Thank you for 9 months. Now Twitch tradition says that this makes you a Twitch sub baby. Now, I am going to fact check that by saying it turns out pregnancies are actually 40 weeks, which is 10 months long. And this is one of those things that I don't know why we don't know, but as someone who has no children, this just reinforces that I made the right decision. 'Cause ow. So welcome for 9 months. Okay, let's see what other questions. Scrolling up to the top, moving the window so that it's easier to read. Yes, brains are for thinking and not for feeding zombies. This is true. Today is the anniversary of the Bruderheim meteorite in 1960, the largest meteorite fall in Canadian history. That is cool. I did not know that. Very cool. So Ruff's Matt asks, where's the Nicaraguan impact crater? I recall a story from a few years ago when an explosion in the ground near Managua Airport was explained as an impact crater, but it wasn't accepted because there was nothing coming from the sky that night. This isn't related to that. This is a crater that formed 800 some odd. Thank you, Disillusioned. Sorry, it's a crater that formed 800,000 some odd years ago. Let me drop the link to the story into the chat. And at the very end of the press release are links to the 2 science papers. Thank you, Bill Nash, for the sub. Today is the day of subbing, and this is so exciting. Bill Nash, that's 5 months. That is excellent. Disillusioned. It's not telling me how many months. Where is it? Thank you for the bits too, Bill Nash. Thank you. So thank you, Disillusion. Thank you, Bill Nash. Thank you, Fenring. Thank you again, Bill Nash. Let's just light up the chat. Thank you, everybody. Thank you so much. Yay, space. Okay, going back to answering questions. Did I actually succeed in dropping the link in, or did I get distracted? I think I got distracted. There's the link in case I forgot to drop it in. So scrolling back to look for questions. So Fenring asks, do we know what the nail is made from? I assume that you mean, oh, I have a dog. I assume that you mean the plunger on the InSight spacecraft. Yes, we do, but I don't actually know off the top of my head. It's fairly robust. I should do a special episode on the InSight mission. I will do that once we have science data back from the various instruments, And so stay tuned, and that will come to you at some point in the future. I'm sorry that that's just not one of those facts I keep in my head. I don't know if they can reel it back, Mr. Tom Harbin. The issue is if it's wending its way down and going around rockets, pulling it straight back up may not be as straightforward as you want. So Henny Zvorvrup is asking, could this be an indication of multiple kinds of dark matter? The explanation that they're trying to use in their research paper is that the material actually behaves differently at different energy levels. And so they're trying to come up with a unified model for dark matter. As I said, though, this is just an early result. My bet is that it's going to turn out to be much more complicated than anything they come up with. So we just don't know yet. So Fenring is saying, does that mean we expect dark matter particles to interact with each other via an unknown force? They actually are figuring out how to have it interacting during completely normal collisional forces. It's just how it interacts is a function of the energies. They haven't had to invoke a new force yet. So Henny is asking, could the type of dark matter cause larger galaxies, or types of galaxies attract different dark matter? We shouldn't. What we're finding is dark matter and luminous matter more or less pool up in the same places, but not completely uniformly the same. Stay tuned. I'm just going to say stay tuned. We don't know yet. Dark matter is annoyingly complicated. Okay, scrolling, going through all of the subs and happiness. So Henny is asking, when meteors hit the ocean, do they make a crater or just float to the ground? We could send a sub to pick it up. Well, the problem is the ocean is vast, and we know, and there's a fabulous Mythbusters on this. Water is really, really good at slowing down objects that hit it. So if a meteor hits the ocean and it's small, it's going to get slowed down and then drift down to the bottom of the ocean. But we can't even find things the size of airplanes at the bottom of the ocean effectively. So there's no way we're going to find a small meteorite. Now, if it's a large meteorite, when it hits, it's going to trigger a tsunami. And then we all die. It turns out that a large meteor hitting the ocean is actually far more destructive than if it hits land, because of the tsunamis that can be triggered. Thank you, Fenring. Thank you so much. That means all the things. I can't read that message from here. I need to switch over to Streamlabs. Hold on. I want to see what your message was. My care package arrived Friday. I'm so glad that it got there and you're pleased. And postage happens. We were pleased to be able to send you things. So thank you. Okay. Going back, looking for questions. So would dark matter need to have its own light to clump at all? Light really doesn't have anything to do with how dark matter clumps. The issue is, how do we see that dark matter is clumping? And the only way we can see it is by how it affects light passing through the system, by gravitationally bending the light. It's super confusing. So Jean Jan Draloon is saying, when things drift down in the ocean, they don't go in straight lines. They can drift hundreds of miles away from the point of sinking. That is entirely true. Things moving down through water is particularly cool to watch and mathematically almost impossible to disentangle. I'm going to pick up the puppy one moment. Come here. Everyone needs a little bit of puppy now and then. So here is Miss Stella, who is no longer the 7-pound puppy that got adopted right before the Hangout-a-thon and that you all got to meet back then. But she is still very much a puppy. And she came in, so I thought she could have time on air. So Larry Weird and Proud is asking, are gravity lenses without an identified lens mass common? We actually haven't found any gravitationally lensed background objects where we can't identify the foreground galaxy cluster or galaxy that's doing the lensing. The trick is microlensing, where we simply see slight distortions in the object that we're looking at. Microlenses, they often are, that is a matter of, we just don't see the stuff, so we're able to infer that there's dark matter out there that we don't otherwise see that is causing the microlensing. Fenrig is asking, would Antarctica be a better continent for finding older impact craters? It turns out that Australia and Canada are the two oldest land masses. So the Canadian Shield is actually a really old thing of rock up in Canada that is some of the oldest rock in the world. And then out in Australia, they also have their own version of that that's extraordinarily old. We will be talking about this in Astronomy Cast, not this Friday, because Fraser is out in Costa Rica, but rather next Friday. So, yes, Paranor, I believe the Canadian Shield is about 3.5 to 4 billion years old. Yeah, it's the oldest rock on Earth that we have been able to identify. Let's see what else I can find. So we find, so Antarctica isn't where it's always been, because land moves, and it's not the oldest land. It's just currently the coldest land. Happy birthday, Paranor. Okay, so I'm not seeing any more questions. Tomorrow, Tuesday, we're going to do a special deep dive. We are going to look at what SpaceX has currently accomplished with their Dragon crew, their human-capable Dragon capsule, and what is left for them to prove in order for them to move into the next step of human tests and eventually human spaceflight. So show up tomorrow, and in addition to the news, we will also be doing a deep dive into everything that we know about the Dragon capsule. And on that note, here is a final reminder. Not your birthday, the Canadian Shield. Okay, fine. Well, we can wish you a happy birthday at the wrong time anyways. So as a final reminder, the Daily Space is a product of CosmoQuest. We are your place to learn and do science. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are here thanks to the generous contributions of people like you. Thank you so much for everything you give. It really matters and helps keep the science flowing. So I am now going to run the credits, and when I am done rolling the credits, I am going to raid on over to somebody else who is talking science to keep the science flowing. So thank you all so much, and wherever you are in the world, have a fabulous morning, evening, afternoon. And if the weather allows, go on outside and take a look up at, well, the stars as the seasons change. Bye-bye.